Welcome to the Deep Dive, where we take a stack of sources, pull out the really important stuff, and help you get well-informed fast.
hmm
Today, we're plunging into a really foundational text in the software world, the Pragmatic Programmer, from Journeyman to Master. And this, well, it isn't just about coding, it's more like a whole philosophy.
That's right. Yeah. For this deep dive, we've got excerpts straight from the book, the preface, bits about its core philosophies, and some, very specific techniques they recommend. It's all about what makes this pragmatic approach so effective.
Right. So our mission today is to unpack the mindset and the practical strategies that can really help you become, well, a more effective, more adaptable, and just more confident programmer. Doesn't matter what your current skill level is or your role. It's about getting things done, and importantly, getting them done well.
hmm
This book, it's got high praise. People like Kent Beck said it's great for keeping the programming process fresh. And Martin Fowler, he loved the mix of solid advice and wonderful analogies.
Yeah. And Ward Cunningham even said it has a philosophy that will ooze into your consciousness. That's quite a statement.
It really is. So we're going to unpack what makes it so impactful and, crucially, how you can actually apply these lessons day to day. So let's kick off. The book really makes you question, what is a programmer? Fundamentally, it seems to go way beyond just, typing code. What's the core idea there?
Well, that's a great place to start because they paint the programmer as a true craftsperson. You're part listener, part advisor, interpreter, sometimes even a bit of a dictator, trying to capture these often vague requirements. And then you have to translate that precisely so a machine gets it right, all while, the clock's ticking. It's like performing these small miracles constantly, turning abstract ideas into working software.
The word pragmatic itself feels really central. Where does that come from?
Yeah, it's from the Latin pragmaticus, which means skilled in business. And that comes from the Greek word for to do. So it's fundamentally about practical stuff, making informed choices based on experience. It's about doing things effectively, not getting lost in, abstract theory.
Okay, and that seems to feed directly into what they call the core attitude.
Right.
Pragmatic programmers aren't just focused on the immediate task.
No, not at all. They're always thinking about the bigger picture, the context, the ripple effects, and they make intelligent compromises to get the job done properly. It's about being adaptable, choosing the right tool for this job, not just the one you know best. And it all starts with tip one: care about your craft. And this isn't just like professional pride, it's the fuel. It drives resilience, continuous learning, stops you burning out. The real insight is that caring, it's not optional, it's essential for quality.
That makes sense. That deep care, that commitment, it feels like the foundation, and it flows naturally into tip two. Think
Yeah.
about your work. That sounds pretty direct.
It is. It's an active thing. You've got to constantly critique, appraise every decision you make every single day. No running on autopilot, like that old IBM motto, right? Think. And the payoff for this active involvement, it's huge. You get a sense of mastery, you improve constantly, and honestly, you find real pleasure in the work. Plus, long term, that thinking time pays off. You get more efficient, the code's easier to maintain, and you probably spend less time in boring meetings because your work just, works.
I love the analogy they use, connecting this to medieval cathedral builders. These were craftspeople, interpreting complex plans, building something immense, way bigger than themselves. It was their belief in their individual contribution that kept those huge projects going.
Exactly. And that connects nicely to the Eaton lawns story, too. Do that for 500 years and you'll have a nice lawn. It's about consistency, small efforts adding up. Great lawns need that daily care, just like great programmers need daily learning and improvement. It's like the Japanese idea of kaizen, loads of small improvements every day. That's how you grow. It's the cumulative effect.
Right, the building on that ownership idea. The book gets really direct about accountability. There's that memorable section, the cat ate my source code. It's about taking charge, owning your mistakes, not being afraid to say, I don't know, or I messed up.
Yeah, and that's summed up perfectly in tip 3. Provide options, don't make lame excuses. Don't just say, can't be done, or it's late, or it's broken. The pragmatic way is to explain what can be done. Offer solutions, maybe refactoring, maybe a prototype, maybe better tests. Ask for help if you need it. Be a problem solver, not just someone who points out problems.
And that proactive approach, it helps fight one of the big silent killers in software entropy, or, software rot. They use the broken window theory from urban decay. Just one unrepaired broken window signals neglect, and then more damage follows. It's like neglect is contagious.
Which leads straight into tip 4. Don't live with broken windows. Fix bad designs, wrong decisions, poor code as soon as you find them. If you can't fix it properly right now, at least board it up.
Yeah.
Comment out the bad code, display a not implemented message, whatever. Stop the rot spreading. That anecdote about the firefighters putting down a mat while a tapestry burned, it sounds extreme, but it shows that mindset. Protect what you can. Don't let small things escalate into disasters.
That really hits home. And the stone soup and boiled frogs analogy, that reinforces it too, doesn't it?
Oh, absolutely. It's a warning. Don't be the frog. Don't get comfortable while the water temperature slowly, dangerously rises. Keep an eye on the big picture. Review what's happening around you, not just your immediate task. It's about vigilance against that slow decay.
So how do we stay vigilant? How do we fight that entropy? The book talks about building a knowledge portfolio. What's that about?
It's basically continuous learning. They suggest reading a technical book, maybe quarterly, reading non-technical books to understand people, keep up with trade mags, online discussions, forums, and really challenge yourself. Learn new languages, new frameworks. Keep sharp, keep broad.
And a huge part of being effective, maybe sometimes overlooked, is communication. They have this wisdom acronym. Can you break that down?
Yeah, it's a handy checklist. What do you want them to learn? What's their interest? How sophisticated is your audience? How much detail do they need? Who should own the information afterward? And importantly, how can you motivate them to actually listen? Thinking through those points really helps tailor your message.
That's useful.
And beyond the acronym, there's some solid practical tips. Know your audience, definitely. Pick the right time, share early drafts, get feedback, be a good listener yourself, that's key, and always get back to people. Even just a quick, got your message, I'll look into it later. With email, the advice is simple but critical. Proofread, check spelling, use plain text if you can, keep quoting minimal. And just remember, email lasts forever. Treat it like a formal document, because often it is.
Okay, let's shift gears a bit. Engineering elegant solutions.
Yeah.
One of the most vital principles, I think, is tackling the evils of duplication. We're always maintaining code, things are always changing, and repeating knowledge everywhere. It's just a recipe for disaster.
Exactly. That brings us to tip 11. DRY, don't repeat yourself. The core idea is simple. Every piece of knowledge must have one single, clear, authoritative place in the system. If you don't stick to that, you get contradictions. Things get out of sync. It's like those sci-fi movies where inconsistent data crashes the alien ship. A practical example is using code generators. If you need, say, a database schema represented in your Java code and your Python code, don't write it twice. Generate one from the other. Or even for the book itself, they generated code examples from tested source to make sure they were correct.
And they specifically warned about impatient duplication, right? Taking shortcuts now that cost you big time later. The Y2K bug being the classic example.
The ultimate example. All that panic because people didn't parameterize date fields properly, didn't centralize date handling, just used 2 digits. Collective laziness, massive global cost, a hard lesson in DRY.
Okay, building on that, orthogonality. They describe it as independence, decoupling. Changes in one place shouldn't break things elsewhere. Can you unpack that a bit?
Yeah, the analogy they use is brilliant. Imagine flying a helicopter where pushing the joystick forward also makes you lose altitude and spin a bit.
Yeah.
Every control messes with every other control. You'd be fighting this incredibly complex system, right? That's like non-orthogonal software. A small change here causes unexpected chaos over there. It's painful.
So the goal is tip 13. Eliminate effects between unrelated things. Design components that are self-contained. Do one thing well.
Precisely. And the benefits are massive. Productivity goes up, changes are local, reuse is easier, risk goes down, the system's less fragile, easier to test, you're not locked into specific vendors or technologies. And this applies everywhere. How you structure teams, how you design system layers, how you refactor code, how you test. It simplifies everything.
And acknowledging that things will change, the book champions reversibility. Because, as they say, nothing is forever. And locking yourself into decisions can be really costly.
This is tip 14. There are no final decisions. Think of decisions like writing in the sand at the beach, not carving them in stone. It means designing for flexibility. Build architectures that can handle different deployment models, standalone, client-server, whatever, just by tweaking a config file, not rewriting the core. It's about enabling adaptability.
Okay, let's dive into the programmer's toolkit. Some really practical strategies here. They make an interesting distinction between tracer bullets and prototypes. What's that about?
Yeah, it's an important difference. Tracer code is lean, but it's complete in a skeletal way. It becomes part of the final system structure. It gives you immediate feedback, a real feel for progress. You always have something working. Prototypes, on the other hand, are about learning. That's TIP 16. Prototype to learn. The value is in the lessons, not the code, which is often disposable. Prototypes answer specific questions. They can ignore correctness, ignore completeness if it helps answer that question quickly. One builds the skeleton, the other explores possibilities.
Got it. Then there's domain languages. The idea is TIP T17. Program close to the problem domain, maybe invent mini languages for your application. How does that help?
It lets you work at a higher level of abstraction, and crucially, you get domain-specific error messages. Instead of syntax error line 42, maybe you get invalid customer ID format. Much more helpful, right? It makes the code clearer for domain experts, too.
Makes sense. What about the dreaded topic of estimating? Any wisdom there?
Well, the main thing is, your estimate should reflect its accuracy. Don't give a single number if it's really a wide range. Be honest about the uncertainty. And often, the best way to estimate is just to ask someone who's done it before. Tap into that collective experience.
Okay, and one of my personal favorites, maybe because it seems so simple but is so powerful, the Power of Plaintext. That's TIP 20. Keep knowledge in plain text. Why is that such a big deal?
It's huge for longevity. Plain text files from decades ago, still readable. It gives you massive leverage with scripting tools, think Perl, Python, shell scripts, and it makes testing so much easier. Even if it seems like it takes more space or maybe a tiny bit more processing, the long-term benefits and flexibility, maintainability, just future-proofing, they almost always win out.
And building on that, shell games leads to tip 21. Learn a text manipulation language. What does mastering the command line unlock?
It frees you from the limitations of GUIs. You can combine commands, do complex ad hoc data transformations, analyze logs, automate little tasks, stuff that would be incredibly clunky or just impossible with a point-and-click interface.
Which ties into power editing in tip 22. Use a single editor well. But this isn't just about being picky, is it?
Not at all. It's about fluency, muscle memory. Your editor should feel like an extension of your hands. Configurable, extensible, programmable. Mastering one tool lets you perform complex edits almost without thinking, which massively speeds things up.
And finally, a really critical one, source code control. Tip 23. Always use source code control. No exceptions.
No exceptions, ever. They call it a time machine for your work. It tracks every change, lets you go back, lets you experiment safely. It's essential for repeatable builds. Even if it's just a tiny personal project, something you'll work on for a week, use Git, use SVN, use something. It's non-negotiable, saves you countless headaches.
Right. Okay, let's move into Pragmatic Paranoia,
Yeah.
which isn't just about not trusting other people's code, but not trusting your own code either. Building defenses against your own mistakes.
Exactly. And a key technique here is design by contract, or DBC, that's TEIP 31. Design with contracts. It means being explicit. What are the preconditions? What must be true before this function runs? What are the post conditions? What will be true after it finishes? What are the invariants? What's always true about this object state? It forces you to think clearly about requirements and helps you avoid just programming by coincidence where the code seems to work, but you don't actually know why.
And if things do break, dead programs tell no lies. Tip 32. Crash early. I like the sound of that. Fail fast.
Fail fast, fail loud. A program that crashes immediately when something's wrong does way less damage than one that limps along, silently corrupting data. It makes bugs obvious, prevents them from hiding and causing more trouble later.
Okay, which connects to assertive programming and tip 33. Use assertions to ensure that it won't. Challenging that, oh, this could never happen thinking.
Right. You should actively add checks for conditions that should be impossible. If you assume a value will always be positive, assert that it's positive. Just be careful about side effects in your assertions. You don't want to create Heisenbugs, those tricky bugs that change when you try to observe them. Assertions validate assumptions. They aren't for handling normal errors.
What about exceptions? The book gives clear guidance in tip 34. Use exceptions for exceptional problems.
Yeah, think of them like fire alarms. You don't pull the alarm to signal lunchtime, right? Exceptions are for truly unexpected, exceptional situations, not for normal program flow control. Overusing them leads to tangled, hard-to-follow spaghetti code. Use them sparingly for genuine errors.
And wrapping up this defensive section, how to balance resources. Tip 35. Finish what you start.
Simple idea. The code that allocates a resource memory, a file handle, a network connection should be responsible for deallocating it. Object-oriented languages help here, like with C++'s autoprocure or Java's finally blocks. They help ensure resources get cleaned up properly, even if errors or exceptions occur, prevents leaks.
Okay, let's look at designing for agility. Now, flexibility, collaboration. We revisit decoupling with tip 36. Minimize coupling between modules. Keeping things independent, avoiding brittle systems. They mentioned shy code.
Yeah, shy code basically means modules shouldn't reveal too much about their internal workings. They should interact through minimal, well-defined interfaces. This reduces dependencies and stops changes in one place rippling uncontrollably through the system.
Then there's metaprogramming and tip 38. Put abstractions in code, details in metadata. What does that mean in practice?
It means write your core code to handle the general case, the abstract idea. Put the specifics, configuration values, business rules, maybe UI layouts into external files, into metadata. This makes your system much more adaptable. You can change behavior by editing the metadata, not by recompiling the code. It makes changes soft, easy to manage. Think configuration over hard coding.
Interesting. What about temporal coupling? Tip 39, analyze workflow to improve concurrency. Use a pina colada example.
Yeah. It shows how, even in a seemingly step-by-step process, like making a drink, there are often activities you can do in parallel. You don't have to wait for the ice to crush before you measure the rum, right? Look for opportunities to run things concurrently to improve performance and responsiveness.
And that applies to system architecture, too.
Definitely. Things like the hungry consumer model for load balancing help decouple components in time. It reinforces tip 41. Always design for concurrency. Even if you don't need it immediately, designing with concurrency in mind often leads to cleaner interfaces and makes scaling up later much easier. It forces you to think about independent units.
A classic pattern they cover is in It's Just a View, tip P42, separate views from models, the MVC pattern.
Right, model view controller. Keep your data, the model, separate from how it's presented, the view. This gives you huge flexibility. You can have multiple views of the same data or change the UI completely without touching the underlying data logic. The Java tree view example shows this, well, changing the display doesn't change the data source.
And for coordinating complex systems, they talk about blackboards, tip P43. Use blackboards to coordinate workflow. How do those work?
Think of a shared space, like a physical blackboard, where different parts of your system agents can post information or read information left by others. Systems like Java spaces work this way. Agents interact anonymously and asynchronously through the blackboard. It simplifies things because components don't need direct connections or interfaces with each other. They just interact with the shared space. Very powerful for distributed systems.
Moving into project realities now. A common pitfall. Programming by coincidence. The code works, but you don't know why. Tip P30, don't program by coincidence.
Yeah, this is crucial. Rely only on things you understand and can depend on. Don't just tweak code until it seems to work for the one test case you tried. Understand why it works. Assume nothing. Prove it.
They also touch on algorithm speed, reminding us about big O notation.
Right. Understanding how algorithms scale is important. Big O notation gives you a way to talk about how runtime or memory use grows with input size. But they also stress, the only timing that counts is the speed of your code running in the production environment with real data. Theory is useful, but reality is the ultimate test.
Then there's refactoring, rewriting, reworking code. They use a gardening metaphor.
Yeah, like weeding, pruning, splitting plants that have grown too big. It's about continuous improvement of the code's internal structure without changing its external behavior. It's not a separate phase. It's something you do all the time.
Which leads to tip 47, refactor early, refactor often. Like dealing with a small problem before it becomes a big one.
Exactly. The medical analogy works too. Remove a small growth early, it's much less painful than major surgery later. But, and this is critical, you absolutely must have good tests in place before you refactor. Otherwise, you're just changing things and hoping for the best. Tests are your safety net.
That's a great point. Which brings us to code that's easy to test. They use a software IC metaphor like integrated circuits, reliable components. Tip 48, design to test. Think about testing from the start.
Yes, before you write code, how will you test this? This influences your design. It means using things like design by contract, writing unit tests for every module, maybe using test harnesses like JUnit or XUnit frameworks. They even suggest maybe building in a simple web server to report status at runtime. Make testability a primary design goal.
What about code you don't write? They warn against evil wizards with tip 50. Don't use wizard code, you don't understand.
Right. Code generation tools can be great, but if you don't understand the code they produce, you're not in control. Debugging becomes a nightmare, maintenance is hard, you lose ownership, understand the magic, or don't use the wizard.
Okay, requirements, often tricky. The requirements pit, tip 51. Don't gather requirements, dig for them. What does that mean?
It means requirements aren't usually just lying there waiting to be collected. They're buried under assumptions, misunderstandings, politics sometimes. You have to actively dig, ask probing questions. Techniques like use cases, like Cockburn's templates, can really help structure that digging process.
Well, you can go too far the other way. Over-specifying. They use the example of trying to write instructions for tying shoelaces.
Yeah, tip 57. Some things are better done than described. If you try to specify every tiny detail up front, you stifle creativity, you remove flexibility, it can lead to rigid, unusable specs. Sometimes you need to leave room for interpretation and discovery during development.
Which ties back to tip 53. Abstractions live longer than details. Like the Y2K problem, again, failure to abstract the concept of a date properly.
Exactly. A good abstraction, like a robust date library, would have handled it. Details change, abstractions endure. They also suggest publishing requirements online, maybe hyperlinked, making them a living document rather than a static, quickly outdated binder on a shelf.
When facing tough problems, solving impossible puzzles, they suggest tip 55. Don't think outside the box, find the box. That sounds counterintuitive.
It does, but it's clever. The idea is often the constraints aren't what you think they are, like the classic 9 dots puzzle. You assume you have to stay within the square the dots form, but that's not actually a rule. Find the real constraints, challenge the assumed ones, and often the impossible problem disappears.
What about working in teams, pragmatic teams?
They advocate organizing teams functionally, minimizing overlap. Apply those same principles, contracts, decoupling, orthogonality to team interactions. Isolate teams from unnecessary changes elsewhere, give them clear ownership, reduces friction, increases efficiency.
A really big idea seems to be ubiquitous automation, quoting Whitehead. Civilization advances by extending the number of important operations we can perform without thinking, like starting a modern car versus an old Model T.
Exactly. Automate everything you can. Builds, tests, deployments, code generation, documentation updates, anything repetitive. If you do it more than once, script it. It saves time, reduces errors, and frees up your brain for actual problem solving.
Which flows perfectly into ruthless testing. Tip 63. Coding ain't done till all the tests run.
Non-negotiable. Test everything. Unit tests, integration tests, performance tests, usability tests, check resource limits, and tip 66. Find bugs once. When a bug slips through your tests, write a new test that catches that specific bug so it never happens again. Build up your test suite relentlessly.
And they make a distinction about test coverage.
Yes. Tip 65. Test state coverage, not code coverage. Don't just aim for hitting every line of code. Focus on testing the significant states your program can be in and the transitions between them. That often finds more meaningful bugs than just raw line coverage.
Okay, nearly there. It's all writing. Tip 68. Build documentation in, don't bolt it on. How does that work?
It means documentation should be part of the development process, not an afterthought. Comments in code should explain the why, not the how the code shows the how. Avoid misleading names they mention the Stroop effect, where seeing the word blue written in red ink causes confusion. Same with code. The ideal. Generate documentation automatically from the source code itself, using markup tools like JavaDoc or Sphinx. Keep comments and code close together.
And a nice final touch. Great expectations. Delight your users.
Yeah, give them that little bit extra they weren't expecting. Maybe thoughtful keyboard shortcuts, a nice custom splash screen, clear error messages. Small things that show care and make the experience better. Surprise and delight.
And the very last tip, bringing it all together. Pride and Prejudice, leading to tip 70. Sign your work.
Just like master craftspeople sign their furniture or paintings. Take pride in what you build. Put your name on it metaphorically or literally. It's a statement of quality and ownership.
Wow. Okay, that was quite a deep dive into the pragmatic programmer.
Yeah.
We've gone from the individual mindset, the craft, through building resilient systems, elegant engineering, the toolkit, handling bugs, designing for change, all the way to project realities and teamwork. It really is about that constant pursuit of, well, excellence and adaptability.
It really is. And maybe as a final thought for you to consider, reflecting on all this, the book mentions this idea of Q1, the quality without a name. It's that sort of intangible sense of real excellence, that mastery that goes beyond just the technical skills, almost artistic, you know? So the question for you is, how can you cultivate that quality in your own work, knowing, as the book says, it doesn't preach, it just tells what works. But in the telling, more comes through. It's about that continuous pragmatic journey of improvement, maybe finding something beyond just the tips themselves.